Hello and welcome to helpyourmath.com. In this video, we are going to look at the zero product property, an introduction to solving quadratic equations or polynomial equations in general by factoring. What is the zero product property? Well, let me tell you. It states that if two factors have a product of zero, two or more factors, I should say, two or more, then one of the factors must be equal to zero. That's the only way we can get a product of zero. The short of this is to say A times B equals 0. If this is true, then either A must equal 0 or B must equal 0, because those are the two things that are being multiplied and their product is 0. That's the only possible way that would be true. When we're looking at this in terms of quadratic equations, we might not necessarily be given just something as simple as A is one factor and B is the other. Generally, we're looking at little binomials. And what we're going to look at in the next video is we're going to start off with this, but I'm going to run us through this. This would be an example of a quadratic equation. Quadratic means the largest exponent is 2, and all variables have exponents that are positive integers. So I see 2, I see 1, and then the 5 is what we call a constant. The goal in the next video is going to be to start with this x squared plus 6x plus 5 equals 0, and figure out for what value or values of x would make this equation true. For us, I'm just going to go ahead and factor this for us. This would factor into x plus 5 times x plus 1. So now I still have two factors here. I have x plus 5 as my first factor and x plus 1 is my second factor. Keeping in mind that a factor, the only thing that's happening to it on its side of the equation is that it's being multiplied to something else. So we would call those things that are being multiplied and multiplied only factors. And then from here, we are going to do exactly what the zero product property states. We're going to set each factor, x plus 5 equals 0, set it equal to 0. And then now we have what's called a linear factor because the exponent of the variable is 1. We're going to solve the linear factor by getting the variable by itself. I'll subtract 5 from both sides, and I get x equals negative 5. That was the first one, right? That was like the A of the A times B. Now let's look at the B. We could also say x plus 1 is equal to 0, and we want to solve this linear equation by subtracting 1 from both sides. I get a second solution of negative 1. In general, quadratics can have at most two finite solutions because of that x squared. The largest exponent is 2. That's kind of an indication we're expecting two solutions or fewer. There could be one, there could be no real number solutions as well. And so this is our goal here with the zero product property. In this video, we're only looking at quadratics or polynomials that are set equal to 0 that are already factored. And then one other caveat to discuss is that if a factor is just a real number, like 7 or negative 4 or a million, we can ignore that factor because that one is not the one that we could set equal to 0. It is itself. So if it's 7, it's 7. We can't change the fact that it's 7. And we'll get into that. There's kind of two options we can do for that. All right, so we're going to practice now using this zero product property. We want to find the possible solutions or the solutions for each of these polynomial equations. This first one is already factored, right? I have two factors. The first factor is x minus 3. The second factor is x plus 5. I'm going to set x minus 3 equal to 0, and then I'm going to solve for x. I'll add 3 to both sides, and I get a solution of x equals 3. And then I would set x plus 5, the second factor, equal to 0. I subtract 5 from both sides, and I get x equals negative 5. So this one had two solutions. There were two x's, so that makes sense that there were up to two solutions, negative 5 and positive 3. And if we wanted to, we could plug these in and check our work. If we plugged in negative 5, we would see that this factor would turn into 0, and then 0 times, that would be negative 8, is 0. Or if we plugged in 3 for x, that would be 3 minus 3 is 0. 0 times 8 is 0. So those are the only two real numbers that make this equation true. Our middle one, I see 3 x's, so I'm expecting up to 3 possible solutions. This so again, we have three factors. The first one is just this x itself. And when we go to set x equal to 0, there's nothing to solve. It's already solved. So one possible solution is that x is 0 itself. In the middle, we say 2x minus 7 could also be 0. And now we're going to solve this one. This one's a little bit more work. I'm going to add 7 to both sides. That gives me 2x equals 7, and then to get x by itself, I'll divide both sides by 2. That gives me x equals 7 over 2. If you want to rewrite it as 3.5 or 3.5, that's totally fine. I think less work is more. Just fine. And then we have x plus 9 equals 0. To get x by itself, we'll subtract 9, and we have x equals minus 9. So this one did have three solutions. We have x is equal to, let's put them in order from least to greatest, -9, 0, and 7 over 2. Okay, now the third one, I see an x squared and then there's another x, so it has up to three solutions. And here's that point that I was making on the last slide. When we're solving for 0, or zeros, we can ignore the constant. So I don't need to include -4 because to say -4 equals 0 doesn't make any sense. That's a contradiction. -4 is -4. If that makes you uncomfortable and you don't like just ignoring one of the factors, first of all, that's very kind of you. And second of all, that's fine. What you can do is you can just lump it in with the x squared. It doesn't matter. So if you lump it in, you could just set this whole monomial equal to 0. And then you would divide both sides by -4. We get x squared equals 0. If x squared equals 0, x must be 0. We could take the square root to undo the square if you want to. Normally we would have to put a plus or minus, but since it's 0, there's only one root of 0 and it's just 0 itself since it's neither positive nor negative. So again, that's up to you. You can ignore the constant that's being multiplied, and it's a factor, right? -4 is a factor of this, or you can kind of lump it in. That might lead to issues. Let me finish this and we'll talk about an issue that might have. Whoa. Okay. The other factor we have is 3x plus 8 equals 0. We'll subtract 8 from both sides. That gets that term containing x by itself, and then we'll divide both sides by 3, giving us x equals -8 over 3. So this one has only two solutions. It could have had 3. The reason it didn't have 3 is because we call 0 a double root since it was x squared. Now I mentioned it's fine to kind of lump in the -4 with the x squared. However, if there was no variable in the coefficient, you're kind of just left with it there and you really can't lump it in with anything else. So for example, if we had 2 times x minus 7 times x plus 5 equals 0, we would just really have to ignore the 2. We can't really lump it in with anything else. I guess you could keep it with the x minus 7, but that's very unusual. So for the sake of finding zeros, we would ignore the 2. And then we would just set x minus 7 equal to 0 and get x equals 7, set x plus 5 equal to 0 and get x equals -5. All right, so now that you are a zero product property connoisseur, expert, you can apply this to unfactored trinomials like we saw in that earlier slide by factoring them first and then setting each factor equal to 0. And that's what you're going to see in the next video. This has been a video on the zero product property. Thank you for stopping by.